And this is also like a recently published paper, like end of June this year. It's called like scaling synthetic data with 1 billion kind of persons. Uh, so yeah, so basically there are like several data synthesis paradigms, right? One is like instance driven, where you just feed a seed corpus to the LM, and then like ask LM or prompt it to generate like more context or more content related to the seed corpus. But it's hard to scale up, and sometimes like it's like really depending on the seed corpus that you fed for the LM to generate the synthetic data sets. The other is like a key point driven, where you provide like list of bullet points or concepts for the LM. I think this one maybe is more related to the PHI model that I presented last time. All right, so it's kind of that textbooks are all you need. Like you need to prompt the LM with a list of key concepts from the textbooks, and then ask LM to create a more comprehensive content by working through all these key points across different levels of granularities, like at high level, low level content. And this paper basically proposed a different framework for the data synthesis is persona driven. At high level, I will think of persona as a latent dimension for the LM. Kind of like you have a world knowledge captured by the parameters of the LM. And it basically like kind of do some compression that the world knowledge are carried by this individual person. I think it's like in real world, the knowledge is also carried by individual person, right? By different occupations or like different people with a different domain knowledge. So basically, it's try to first compress the knowledge of the LM into 1 billion persons, like of different occupations and different kind of knowledge or expertise. And then these persons are kind of the basically in your prompt is the role you put in your prompt, and then you can ask it to generate like more prompts like more related to the role, right? And then you can decompress. Basically, it's called like a decompress process to kind of generate the world knowledge by each of the role you have extracted. So that's kind of the overall framework. So this is some like examples where you kind of first create these different persons, like a moving company driver, a chemistry researcher, a more musician. And for different profession, you can prompt like basically use the same prompt. Like for example, create a math problem, create a logical problem, or you ask it to say, if you are this role, what prompt would you give to the LM to help your job, for example, right? And then it may, based on like a different roles, it will give like a different kind of the questions. It will generate different questions, a different problem or instructing prompts for the LM based on different persons. So these personas can work with a wide range of data synthesis prompts, and actually the same prompt can be used, and you can use these personas to scale, right? Basically, I'll just create a math problem, and then you can end up with like say if it's like 1 billion, then you can end up with the 1 billion math problem, just by using the same prompt with this like a different persons in your prompt. So that's a text to persona, and this approach is basically, I think, it's a very simple prompt. They use is just like who is likely to read, write, like, dislike, or judge, right? Kind of like the input text. So these texts are from the corpus you have, and then you give the LM and ask the LM like who is going to read or understand this, who is going to like this, or able to judge whether it is correct or not, right? So you can use these prompts and then ask LM to answer the who kind of question. And then based on the input text, it will generate, oh, this is a machine learning researcher, this could be a nurse, and this can be like gaming, mobile gaming enthusiastic. They also can give like a very detailed text. They find like, for example, if you pass in like a very detailed math problem, like a linear algebra, or this is like a very detailed questions in superconductivity, and then LM also will give like a very detailed profiling of the persona, right? Like it's not just like a mathematician, but also like it needs to understand like linear algebra, etc. It needs to understand the linear algebra, etc. to so that they can answer this problem. For example, also here, right? So based on the inputs, like how detailed your input is, it may generate like a persona with different levels of profiling, like brief one, or even like a persona like with very detailed descriptions and expertise. It also proposed like persona to persona. So basically, like once you pass your first round, you extract a persona, and then you reprompt the LM to generate who are the possible other personas that are kind of has interpersonal relationships, right? For example, here is a nurse, and then the LM may say, oh, there's a medical supplier, maybe it's like this pharmacist who is a medical supplier for the nurse, and there's like a patient persona, like who has some like medical conditions, and also it could be like colleague, right? So it basically kind of multiply the personas that you have based on like a different relationship it has. And then yeah, they also mentioned about the deduplication. I think it's kind of the same deduplication that we need to do for the text LLM, because it's LLM, right? It generates lots of similar personas directly from that. So it mainly uses like a min hash deduplication, because the personas just like a 1-2 sentences, and they use like a 1 gram, just one token, and use like this min hash for the deduplication. That's the first layer. The second layer just like a embedding based, just like a very straightforward embedding based, and they filter out the ones with a semantic similarity greater than 0.9. Okay, so that's all the personas. So basically, I think they generate like a 1 billion personas this way, also with all these additional filterings, and they have released about a few millions publicly. Open source, they are still like on the way to release the rest of the persona hub as an open source dataset. And so once we have the personas, how can we generate the data? It can be like the template, like for example, just create a challenging math problem with the following personas, right? So like whether it's a chemistry, whether it's like a mathematician or mathematician with a certain expertise, it may generate like a different math problems. Or you can have like a few shot prompting for this, or you can also have the persona enhanced. So basically the examples is given like a different personas, and then this is a math problem generated. Like the volleyball player was a math problem, mathematicians specialize in this, what is the math problem, and then if the person says what is the math problem. There. So this is the prompts they use. So there are several use cases that they have mentioned. The first is math, right? So basically, like for example, here you can promptly say like create a math problem, or create a geometry problem, or you create like a very difficult level math problem. So basically, you can also vary the difficulty levels of the math, and then basically just replace this with the personas you extract, and then you end up with lots of problems. for that. So like this is like linguistic, and this one is like with like particular interest in language and social interactions. And then that's a different like a geometry kind of problem. And this is like a very difficult one, like Olympiad level math problems over there. And they select basically like 1 million personas from the persona hub, and then they just in this evaluation, they employ like a zero shot prompting using GPT-4 to create the math problem with these personas. And then they switch to GPT-4o. I don't know why they switch. They switch to GPT-4o assistant. Maybe the assistant is better to understanding the rules, and to generate the solutions to the created problems. And among these 1 million math problems, like kind of like one person has one problem and has one solution generated, they hold out like 20K as a synthetic test set for the evaluation, and the remaining as the training set. So the evaluation data set they have is this synthetic test sets, like it's the kind of like an in distribution test set, and they also have like a out of distribution math. So this is kind of like a standardized math set that are like all the closed source, open source LLMs are evaluated against it to test the math capabilities. Oh, they also specify, I think this is also interesting, like they only the task instances to make sure that it's more accurate. They basically prompt like a different GPT-4, and then they only retain the task instances where at least 2 solutions are consistent. So they kind of cut it by half to make kind of like the math problem is kind of like deterministic, I guess, most of the problem. And then they need to make sure that the answers has to be consistent by at least like 2 GPT-4 here. So they end up with like about 11K test instances from the synthetic test set. And how they evaluate it, they just do the equality checking. So I think OpenAI has published an evaluation protocol, like using the LM as the evaluator, right? They just use the LM to see whether the 2 answers are equal or not. But because they use GPT-4 to, I guess because they use GPT-4 to do the like the dataset generation. So they choose like a Llama 3 instruct as the judger to judge whether the say the model, the trained model, the output from that is equal or consistent to the ground truth answers. Yeah. So that's how they set up the framework. And basically they train a 7 billion QWEN2 model, fine-tuned with this 1 million synthetic instances, right? So the model size is like 7 billion, and this is just for math. And this is the accuracy. I think this is on the in distribution test set they have. So about 11K synthetic test set. And this is the other like a GPT-4 performance on that. And this is like more of the open source LM with like a varying different size. And it shows that this 7 billion like fine-tuned on this synthetic data set is able to kind of have some degree of strong math capabilities, kind of like a distilled from GPT-4, and have strong capabilities in math comparing to this open source models. They also have the evaluation on the math, like out of distribution test set, and you see the performance. So actually on this data set, it has comparable performance to the GPT-4 Turbo Preview, like around 64% accuracy. And also like you see like a Cloud 3.5 is already also high, but like since there are like multiple versions of GPT-4, also 4.0. The main version does have a boost in the math capabilities there. I think the conclusion they're trying to make is the model fine-tuned with their synthetic 1 million math problem datasets is able to match the performance of the GPT-4. Who knows, like what is the size? Maybe hundreds of billions of parameters, like at a 7 billion scale. So that's the conclusion they want to make. And they also showing the kind of the scalabilities of by increasing the synthetic samples, you see the increase of the accuracy. And this is where they see like they can exceed the performance of GPT-4 Turbo, and there's still room for improving by using more synthetic data sets to train the model. It's not saturated yet. So that's the math problem. They also mentioned about other potential problems. For example, for the logical reasonings, right? It's the same. You can just create a logical reasoning problem with the following persona, create a spatial reasoning with the personal following persona, right? And it can give like a different text. For example, if you want to train another LM, just focus on reasoning, you can, this is how you distill it. Also like on instruction following, right? Like you are a helpful assistant, gets a prompt that the following persona may ask you to do, kind of reverse it, reverse the direction, ask the assistant to predict what are the potential instructions that's the following persona may ask you to do. It kind of inverse the direction to ask to generate the prompts. And also you can help with the knowledge-rich text, right? For example, ask the persona to write a Quora article using the knowledge, skills, experience, and insights, etc. So this is like a synthetic text generated. They also mentioned something about like a tool development, because it's very easy to tie a tool to an occupation, right? Like whether it's like a virtual tool or like a physical tool. But here is they many mention about the virtual tool, like kind of like a CodeNet, coding, a small coding tool that the LLM can invoke. So basically, like with different personas, you may have like a different definitions of the tools you want to, or functions you want to call, and it can generate like very detailed descriptions, what is the functioning, what is the input arguments, and what is the returning output. And they also mentioned that they can use this for the code generation. So basically, it's kind of like a scaling the tooling development for the LM to call, right? So that, for example, for this, it can generate another like a code segment based on this, because it's like a very clear requirement and inputs outputs expectations from that. But they haven't shown any results on that. But that's they mentioned that this is something that they will explore next for this scaling of the tools based on different persons. So this is some conclusion from the paper. This is also how I think about it. So some inspirations from this paper. So basically they think that the LLM should not be just limited to processing the data, but they can also create new data from a scalable magnitude or perspective. Kind of you create a virtual world with all these different rules and persons in the virtual world, right? And you kind of like trying to simulate the real world by this approach. They also mentioned that today's LLM is still not able yet to kind of converting, kind of make sure that all the data they generated are true and realistic, because it's still like a hallucination is still inevitable, and the quality of the data is still limited. So This is like a current status of this. And also like they think this is approach that can like to mimic the real world so that we can run some reality simulations with this. And also this framework gives a path for the full memory access of the LLM. So it's more like for the model distillations of how we can compress the LLM, right? So like LLM is like a compression of the world knowledge, and then the personal halves can be like a distributed carriers of the world knowledge, just like in the real world, how each individual person is carrying the knowledge of the world. So they are also thinking about whether there's any possibilities to create some super, kind of like a Superman, Superwoman, super personas to even create new knowledge, like just move beyond the scope of existing knowledge. So because they are, because personas are kind of the carriers of knowledge, like whether if that persona has really strong capabilities, right? Like whether it can create like a new knowledge beyond what is already known here. So I think it's a very interesting framework. And I'm also thinking about like whether the personas can be replaced by like a different product experts, like relates back to our work, like whether the personas can be replaced by like a different subject matter experts with a different product expertise, right? And I'm wondering like what personas it will create from that.